We begin our tour in the Irish Midlands, here in Birr, County Offaly. Birr Castel Demesne is home to two world-class telescopes, spanning historical astronomy research from the 19th century right up to the modern day. Firstly, we have the Great Leviathan Telescope, built in the 1840s by the 3rd Earl of Ross, William Parsons. Completed in 1845, this was the largest telescope in the world for over 70 years, only overtaken by the Hooker Telescope in California in the USA in 1917. William Parsons was married to Mary Fields, who was also interested in astronomy and was an avid photographer and had architectural and engineering skills. It is mainly thanks to her fortune that they were able to build the Leviathan Telescope. She is also responsible for designing the supporting walls on either side of the Great Telescope. The Leviathan is a 6-foot or 72-inch telescope, referring to the aperture size, which is the diameter of the telescope tube, around 1.8 metres across. The tube is 54 foot in length, about 17 metres, with a curved concave mirror at the base. This mirror is made of speculum, a mixture of tin and copper which can be polished to give a very reflective surface. The 3rd Earl spent a lot of time experimenting with the ratios of tin to copper to create a material which was reflective without being too brittle. 2 6-foot mirrors were made in the furnace in the workshops here at Birr Castle, each around 6 inches thick and weighing about 3 tons. The mirrors had to be allowed to cool slowly over a number of months to prevent them from cracking. Each also needed to be supported in a wooden mirror cell or box to prevent it from deforming under its own weight. These mirrors were tarnished quickly in the damp air here in Birr, so when one was being used, the other was being polished. As you can imagine, moving these giant, heavy mirrors was quite difficult, so a railway track was constructed from the workshops at the castle to the base of the Leviathan Telescope to allow them to be easily switched for cleaning and polishing. The large telescope tube was made by the coopers or barrel makers in Guinness's workshops on Cork Street in Dublin, and then transported along the canal to Tullamore before making its way to Birr. The telescope can be moved from the angle you see it at here through a range of altitudes all the way to the zenith, meaning it is pointing straight up. It can also move in a limited azimuth range or side to side, allowing an object to be tracked across the sky for about 1 hour. You can see the chains and counterweights to keep the telescope in balance and the winch to raise it up. The optics of this telescope are quite straightforward. Light enters at the top of the telescope tube, travels down to the primary mirror and is reflected. Due to the curve of this mirror, the light is reflected back up along the tube to a single point, similar to how your face appears upside down when you look at your reflection in a spoon. When the reflected light travels back up the tube, it converges at a point. This is where the secondary mirror is placed at an angle. The light bounces off this and is reflected into the eyepiece to the observer. All of the observations from the 1840s were recorded through notes and sketches drawn by the observer, either the 3rd Earl or other visiting astronomers who had come to Birr to use the telescope. One very important thing the 3rd Earl looked at was a nebula known as M51. In the 1840s, many objects in the night sky which appeared as undefined bright regions were classed as nebulae, as the telescopes at the time were now powerful enough to make out specific details. When the 3rd Earl looked at M51 with the Leviathan Telescope, he could make out light and dark patches and noticed that these were in a spiral shape. He named it the Whirlpool Nebula, as it reminded him of small whirlpools which form in the rivers and lakes around Birr Castel Demesne. We now know that this is the Whirlpool Galaxy and that a lot of galaxies have this spiral structure, including our own Milky Way galaxy. You can see here the sketch of the Whirlpool Galaxy drawn by the 3rd Earl in 1845 and a photograph of the same Whirlpool Galaxy taken by the Hubble Space Telescope in the 1990s. The Parsons family of Birr Castle were very interested not only in astronomy but also in engineering, photography and horticulture. Birr has a rich history of astronomy and being at the cutting edge of research, which has continued here today with the Ilo Fire Telescope. We'll take a short stroll through the gardens and travel nearly 200 years from the 19th century to the present day to see our 21st century telescope. I-LOFAR is the Irish Low Frequency Array and is a radio telescope observing the universe at low frequencies between 10 and 240 megahertz. To understand how we observe radio light, we'll take a look at the electromagnetic spectrum, which is a spectrum or range of all the different types of light. In the middle we have visible or optical light, which, as the name suggests, is visible to our eyes. Either side of that there are other types of light. Just past purple you have ultraviolet or UV light, then at higher frequencies and shorter wavelengths there are X-rays and then gamma rays. On the other side, just past red, you have infrared light, then getting to lower frequencies and longer wavelengths, there are microwaves and finally radio waves. These are all various types of light which we may not be able to see, but we can build machines that can see them, such as radio telescopes. When you think of radio telescopes, you may picture a large parabolic dish similar to a TV satellite dish. There are some radio telescopes which are like this, but as you can see, I-LOFAR is not. It is an array, meaning it is made up of many smaller antennae linked together to effectively act as one large dish. These antennae here in Birr cover an area about the size of a football field. I-LOFAR was constructed in Birr in the summer of 2017 by a team of mostly undergraduate science and engineering students. It was mainly funded by Science Foundation Ireland and is run by a consortium of third-level institutions across Ireland led by Trinity College Dublin and including NUI Galway, University College Cork, Athlone IT, University College Dublin, Dublin City University, Dublin Institute of Advanced Studies and Armagh Observatory. I-LOFAR was built here in Birr as it is a region with very little radio frequency interference which would drown out the radio signals coming from space, similar to how light pollution in cities prevents you from being able to see the stars in the night sky. This makes it an ideal location, and as radio astronomy can be done day and night and in all weathers, it is well suited to the Irish Midlands. There are two different types of antennae that make up I-LOFAR. Here we have the low band antennae, optimized to observe between 10 and 90 megahertz. You can see the large pole in the center holding up two wires. These wires are the antennae at 90 degrees to each other. The grid at the base is rebar, a common building material that acts as a reflector here, similar to the large mirror in the old Leviathan Telescope, and reflects the weak radio waves coming from space back onto the antenna, allowing them to pick up the signal. There are 96 of these tiles here, so 192 low-band antennae. All of the information recorded by these are sent by coax cable to the control unit here on the field. Similarly, we have the high-band antennae. There are also 96 tiles here, each containing 16 smaller tiles with two antennae, so there are over 3,000 high-band antennae on the field. These observe between 110 and 240 megahertz. You'll notice that we have left a gap between 90 and 110 megahertz, as this is the band that the terrestrial FM radio stations broadcast in. These would be a lot stronger and drown out the weak signals coming from space, so there would be no point in observing in this band. There are many benefits to building an array like this over a large single-dish telescope. Firstly, this is a much more cost-effective way of building a large telescope, and won't collapse under its own weight as some large dishes have. It is also possible to effectively point the I-LOFAR station in a particular direction electronically by phase delays between the antennae, allowing researchers to look at particular objects in the sky. This I-LOFAR array is large and very useful when used on its own in local mode, but it really becomes more powerful when linked up with the other LOFAR stations across Europe. There are 12 other international stations, just like the one here in Birr, across the UK, France, Sweden, Germany, Poland and Latvia, along with a collection of remote and core stations in the Netherlands where LOFAR began. When the stations are all linked up together in international mode, it is as if we have one enormous radio dish stretching from Birr to Latvia with a baseline of over 2,000 kilometers. This allows researchers across Europe to see bodies further away in space and to observe them in more detail, allowing us to increase our understanding and make new discoveries. I-LOFAR is connected to the core by a 10 gigabit fibre optic cable, and when in international mode, transmits 3 gigabits every second to the Netherlands. The entire LOFAR array, when used all together, generates a data flow of over 200 gigabits per second, roughly 2,000 times faster than the average household internet connection speed. Some of the research LOFAR is used for includes solar physics and space weather research, understanding the impact the sun's activity has on us here on Earth, as well as observing known galaxies and discovering new ones, studying pulsars, and looking far away in space to learn more about the early universe. We also have the I-LOFAR Education Centre here, where we run our Astronomical Midlands Education and Public Engagement programme. This involves inviting members of the public, visitors to Birr Castel Demesne, special interest groups and school students to come and learn more about the research done with I-LOFAR, as well as exploring many other aspects of astrophysics and astronomy. We also host conferences and community events here and in Birr Town. To learn more about the Astronomical Midlands programme and available resources, or to find out more about other areas of research the I-LOFAR team and wider international LOFAR teams are working on, go to our website at lofar.ie. The I-LOFAR Telescope is a modern astrophysics research instrument used by an international team of scientists. It is part of something greater that will continue to increase humanity's understanding of the universe and continue to position Birr as a centre for world-class astronomy research.